Hey, this is Donald Heslop, dual CCIE and owner and principal of Padlock Technologies. I'm going to talk about an advanced network topic. We're going to talk about VXLAN and the different flavors of VXLAN, some of the control plane stuff, some of the data plane stuff, or we'll just talk about some setups here. So what I'm going to compare today is going to be MP-BGP EVPN versus an ACI or a data center fabric versus SDA, which is VXLAN data plane, but the control plane is Lisp. So it's a little bit different. So let's get on the whiteboard. So the first one we're going to do today is your traditional, let's make sure we got this here. MP, multi-protocol BGP address family EVPN. Now, you can do this with Nexus switches. You can do this with CSRs. You can do this with, anything that has this address family capability, right? And it can be exchanged in the open message of BGP when you're establishing the neighborship. So we're first going to talk about MP-BGP EVPN. Now, if anyone has done this the manual way, there's a lot of pieces in here. Why would you do a technology like this? Well, you are trying to eliminate spanning tree everywhere in your environment. Spanning tree is super old. I mean, if you've done anything with VLANs and, PVST, rapid PVST, MSTP, which is multi-spanning tree, which is, you can map multiple instance of STP or spanning tree to a instance, right? And that has its own configurations. But here's the thing, in the data center, you do not want spanning tree in your data center. Why? Because those links can be 40 gig, maybe 60 gig, 100 gig links. Those links cost a lot of money, and the last thing you want to do is have those links in blocking mode if you're using traditional spanning tree and wasting a whole bunch of money. Now you're probably going to say, oh, you can use port channel. Yes, you can use port channel as well. But there is one key disadvantage of using spanning tree, no matter what it is. It's one key disadvantage, and that is there is no TTL value in layer 2. That means if you have a spanning tree loop in your environment, it will basically nuke your environment and you will be down. This is why collapsed core design is kind of like iffy, right? If you're going to do a collapsed core, if you have a spanning tree issue, yeah, everything's going to be down because there's no TTL. At least on layer 3, the TTL goes all the way up to 255, and then it just dies out. So you might have a loop, but it won't be as long as or infinite as a layer 2 loop. So we're talking about the traditional data center. Now, what I'm going to explain here is also how ACI does it, especially if you do network-centric mode. Nobody really does application-centric mode, by the way, because if you don't know how your applications talk, you can't really do application-centric mode because you can't create the right context. We'll get into that into another video. So the first thing we're going to talk about is cross fabric. So what's the cross fabric? Basically, a cross fabric is spine leaf topology, right? And everybody's connected to everybody here, right? Spine is connected to leaves, leaves connected to spine. All right. Now, what happens is everything in this connection from all of this here is layer 3, right? And then everything below, so you got to switch here, is what they call CE, or classic Ethernet. So your classic spanning tree domain. So from a data plane standpoint, uses VXLAN. What VXLAN basically is you're going to be tunneling between these endpoints. And the benefit of this is you're going to do something called ECMP, which is you have multiple links, like if you have more spines, and it doesn't have to be just 2 spines. You can have infinite number of spines, infinite number of leaves, as long as they connect together. And then you're going to tunnel L2, and this is when you want to do, stretch the VLAN amongst all these nodes here. And that's one of the benefits. You can stretch VLANs across the fabric. So you have classic Ethernet when it comes going downstream, and then upstream it got something called a VNI. Right? So what the VNI is it's specific to VXLAN. Right? So VXLAN will basically say, I know about the VNI, but then when it gets to the other end, it strips out the VNI and this classic Ethernet going back down. So it'll be VLAN 10, and you map these VNIs to VLANs. So for example, I can have VLAN 10 mapped to VN, and they call it a VN segment when you use Nexus. VN, and that's a VNI 1010. So VXLAN will basically say, okay, I'm going to do multicast, and I'm going to listen for any traffic or anything that's going to, and this is a virtual tunnel interface or virtual network interface, is going to create these tunnels, and then I'm going to encapsulate that in the VXLAN packet, and then send it via, you think of it like GRE tunnels between these edge nodes, or VTEPs as they call it, virtual tunnel endpoints, and then you can basically stretch your layer 2 domain in the fabric. There's also a multi-site component to this where you can have different geographical locations for different VXLAN fabrics, and then you stretch your VLAN 10 across geographic locations through this thing called MP-BGP EVPN multi-site, which is a long thing to say. But what that basically means is you would have an edge switch that would be your border node, border router in traditional VXLAN talk. So you have your border router, and then it would connect through a DCI, and you use ingress replication when you want to stretch your VLAN to the next site. It'll be multi-site ingress replication. And then you have your DCI tracking, which is going to the DCI, and then you have your fabric tracking. And what does that do? That basically means if one of these fabric tracking links go down, it will bring down the stretching VLAN. If the DCI link goes down, it checks it to make sure it's up. If it goes down, it will bring down the stretch between data centers. So the beauty of this is you also have multicast in here, right? Now the multicast that I suggest you use is BSR, because you can take advantage of this thing called Phantom RP. So what Phantom RP is between the two switches, you will do something called a longest match. Basic routing rules. Longest match wins, right? So this, say this switch over here is a /29, and then I make this I'll make this a /30 actually. Let's say /30 over here, and then we'll do a /28. So when I do my RP, or Phantom RP, I will pick an address that fits in both subnets. And then from a multicast perspective, when you're going to do, and this is going to be biter, by the way, when you're going to send those multicast packets, or when you're trying to join a tree or share tree, since you're going to do biter, because there's no share tree or no source tree in biter PIM. By the way, when you go to join for certain multicast groups, when you map the multicast group or when you map the VNI to a certain multicast group, it sends that join message to the RP that's the closest, that matches the longest match, even though it doesn't exist technically in the routing table. It's just going to say, okay, well, from a Phantom RP perspective, okay, well, that subnet is longest match wise on this spine. So I'm going to just send all my multicast joins over there. So everybody's going to join a certain multicast group, so they're listening for packets, the initial packets, right? Oh, let me send my broadcast that's going to end up going to be a multicast packet, and then everybody's listening to that multicast channel. We'll get the packet, and then when it gets downstream to the actual endpoint, then it's just going to be unicast between the two endpoints. That's if you're not using like ARP suppression or anything like that. So that's MP-BGP EVPN. This is what ACI does. Now the multi-site and ACI is a little bit different because you're going to be using the spines to do the multi-site, and compared to traditional MPB, EVPN, VXLAN multi-site, which is going to have that border router. It's going to treat the spine as a border router, and then you'll have like other switches or your core switch on top. You're going to have a separate VRF table because you do not want those routes showing up in your global routing table. It's a whole different design. So this is your traditional. This is what you would see in traditional, manual VXLAN or traditional VXLAN, and then ACI does this. Okay, so now what is the difference between that and SDA? Same concept, different control plane. So with this, you're going to have a couple components here. So one's going to be a fusion router. Now that doesn't necessarily have to be a router per se. Then that's going to get connected to your border nodes. Let's say we got border nodes, VNs, and here you can have what they call a known border. So these are for known routes. Then you can have unknown border, which is for internet, basically how you get out to the internet. Say there was a firewall over here or something like that. How you get out to the internet, it advertises the quad zeros down. All right, and then everybody would go to this border when they want to get out to the internet. But if you combine the two, this is called an anywhere border. Okay, now between the fusion and the border nodes, you are running your classic MP-BGP, right? Because the border nodes are going to send whatever networks you could create called VNs. It's going to create a separate address family for each VN you create. So you'll have your infra VN, then you'll have custom, corporate, then you'll have guest, and then you'll have IoT. So it'll look like this. Now these lines represent different VRF address families that get activated on the border node. Now, down at the bottom, I'm going to put green. I'm going to put a big cloud here. All right. So this is called intermediate switches. Right. These are just switches that allow connectivity from the border nodes to everything else. All right. And then down at the bottom, instead of calling these VTEPs, which is virtual tunnel endpoints, I gotta erase that because that was a bad line there. Instead of calling these VTEPs, they actually call these fabric edges, so FNs, or fabric nodes, if you want to call it that. Fabric nodes. And then your endpoints plug in here. Now, one concept I forgot to mention on the other with the MP-BGP EVPN is there is a concept called Anycast gateway. So what Anycast gateway is, it allows you to have the same default gateway on any switch, no matter where they are on the network. What's the benefit of that? Well, VM mobility and just workload mobility. I can move workloads to any switch and never have to worry about the default gateway. It's always going to be the same. The MAC address is going to be the same. I don't have to worry about ARP issues. Oh, I need to make sure ARP clears before I'm able to send traffic, right? You don't have to worry about that anymore. You could just move it anywhere in the network or in the fabric, and the default gateway is the same. Even if they're geographically in a totally different area, you can still do that. So the fabric edge or the fabric nodes is where your endpoints plug in. And then from a control plane perspective, they have this thing called a control plane node. Now the control plane nodes are going to run this protocol called Lisp. All right? And Lisp is going to keep track of where every host is and what switch they're technically connected to, right? Think about it. If you know Lisp, they call it like DNS for routing. Pretty much, they got RLOCs, which is router locators, and then behind the router locator, these would technically be mapping servers on the CPs or the control plane nodes. They would be mapping servers. They would know all the mapping, IP mappings to fabric edge nodes, and then, you know, when I need the fabric edge would query, if I don't know about where something is, I'm going to query the CP node and say, hey, who owns this subnet? Who owns this /32? Now, traditionally, when you're talking about whether it's the traditional MP-BGP, EVPN, ACI, doesn't matter. It's all /32s, right? Because in the traditional sense, you can do it in such a way where we're not going to do the /32s. We're going to do just the subnets. But it's better to do the /32s. It's a lot. It's simpler doing it that way than to do subnets, right? And those are going to be type 2 routes anyway. It's called the type 2 routes are IP to MAC, right? So your /32 to MAC address. Type 1 routes are your auto discovery routes, or how the fabric edges find each other. Type 3s are multicast routes. Type 4s are this thing called designated forwarders, but if you're using like our ESI, Ethernet segment identifiers, stuff like that, will get found there. Like if you're doing VPC, and there's a certain thing called designated forwarder rule to avoid you getting double packets downstream. I'll get into that into like probably another video, because that's a crucial concept. Type 5 routes are external routes. These are your routes that are not /32 routes. Type 6 is, don't quote me on this, I believe type 6 are source routes. Like if you're going to do multicast, you might see certain multicast, like a shared tree, I think it's type 7. The shortest path tree is a type 6. Don't quote me on that though, because sometimes I get those mixed up. So from a connection standpoint, everything is going to be connected in. Now, they don't have to be connected directly to the border node. They just need to have reachability, right? So I'm just doing this as just simulating the reachability here. Same design, right? So after the fusion router, they call this shared services. This is where, you know, things like ICE, AD, WLC, things that are going to be shared services. Now, the WLC, there's two ways to do this. There's fabric-enabled wireless, which would be in the fabric, and then they have this thing called over-the-top. So what over-the-top is you'd have an AP over here, right? Gets on the network, and then it forms the cat web tunnel back to the WLC. When people actually connect to the AP, they are not actually going through the fabric anymore. They're not going through the fabric per se. Their traffic is getting tunneled to the WLC and then popping out on the other end. All right, so that's what they call OTT, over the top. Fabric-enabled wireless would actually be going through the fabric. SDA is mainly going to be used for a campus design. That's really what it's used for. And if you really look at how Cisco's kind of navigating this, it would look like this. So your campus network, and I'm just going to draw the box. So campus network, just simulate this, would be SDA. SDA, right? Once it gets to the fusion, to the shared services, so fusion here, you would have something like, I'll draw it over here, traditional. It can be MP, BGP, EVPN, or ACI, would hook into this fusion, however it gets there. Now, this is going to be a little bit different. This is called an L3 out in ACI world. L3, not LE. And then in traditional MP-BGP EVPN, this is just VRF Lite, right? So the VRF Lite is basically going to be an interface that's in the VRF, and then you're either going to do BGP to the fusion router, or you're going to do OSPF and, you know, redistribute the routes so that when I get to the fusion, I'm going to advertise these routes into SDA so that all my fabric nodes down here at the bottom No, hey, if I want to get to any of these routes here, I need to travel through the fabric to the Fusion to ACI or traditional MP-BGP EVPN. Now, that's the future, right? The other thing is WAN connectivity. So from a WAN connectivity perspective, guess what you have over here? You have C edges, CEs, right? C edges. Now, I'm not talking about CEs in terms of service provider or MPLS, stuff like that. And this would technically be SD-WAN. So that other sites, let's say we have a site here, site here, site here. These sites, and they would have their own CE. And then you have, let's say, a cloud here, INET. And then you have your tunnels. All right, so this is BR1, so branch 1, branch 2, branch 3. And now when I want to get to any kind of fabric like ACI, I would use SD-WAN to now get my traffic from branch 1 to CE to Fusion to resource. Now, you could use the Fusion router to get there, or in the data center, you can have your own CEs, and they'll bypass all of this, and everybody's traffic would basically go over the internet to go this way to each CE, right? Because you don't really want to backhaul all that traffic to the Fusion router back. From a design perspective, you kind of want to have SD-WAN set up where the campus is only going to use SD-WAN to either A, get to other branch sites, which I don't know if they would ever need to do that, or you're doing some type of other design. This here, as long as your Fusion router could technically, let's say if we got rid of this L3 out or VRF Lite, that L3 out could be somewhere in the data center. The Fusion router would go to the CEs to get the shared services, and then shared services CE will go through the internet or the SD-WAN fabric to get to the data center. Also, you can do this and get to the cloud through your SD-WAN backend if you wanted to do that. This L3 out and VRF Lite is only if you have a direct connection between your data centers and headquarters, right? If you don't have that, then you need to have some kind of WAN infrastructure, preferably SD-WAN, or you can use VPNs as well, route-based VPNs, because they're a lot easier to get to your resources. Shared services, I want to make this very clear. Shared services does not need to be connected to the Fusion router. The Fusion router is just how you get out to shared services. It doesn't need to connect directly to shared services. So that was a brief overview. Oh, and I wouldn't even say a brief overview. That was an overview of MP-BGP EVPN traditional, what ACI does behind the scenes for you if you ever get ACI, and SDA, which is basically the same, but the control plane is different because you're using lists versus, BGP, right? You're not using BGP in the traditional sense of an ACI fabric, because ACI uses ISIS and BGP for control plane. SDA uses ISIS lists as control plane, but they both use VXLAN for data plane. And they got different use cases. ACI, traditional BGP EVPN, is more of your data center, right? You want to connect two data centers instead of doing something like an L2 VPN, like a VPLS, or you can technically use EVPN for that to stretch it. But let's say you don't want to use your traditional VPWS or VPLS, which is virtual private LAN services versus virtual private wire services, pseudo wire versus a full mesh of pseudo wires, basically. And you have different modes there, Capella versus Martini. Instead of doing that, you're going to use VXLAN BGP EVPN to stretch your layer 2 domain over L3, all right? And with SDA, that is going to be in the campus side of the network, and that's going to use the same VXLAN for data plane. It is going to use Lisp as the control plane, BGP going to the fusion router, and then it uses ISIS. Now, the one caveat, if you're going to do this, say, the traditional method of MP-BGP EVPN in the data center, you don't have to use ISIS. It's just, now we're going to get into a routing conversation, which is ISIS versus OSPF. They're both league state protocols. Here's the thing, though. ISIS is more scalable because you don't have to rewrite the entire protocol to add new features. They have this thing called TLVs, and all you have to do is write a new TLV. Compared to OSPF, which you got to write an entire different protocol. Case in point, OSPF v2 versus v3. V3 is IPv6. Well, they have ISIS for IPv6, but it's multi-topology, and they just added a TLV to that. That's why they're coming back, and you're seeing a lot of ISIS being put in these technologies because it's scalable, and we don't have to worry about recreating a brand new protocol for that to work. If you are looking for this type of design or you need some help on your next infrastructure project, I'm going to leave a link in the description. You can schedule a discovery call. Again, this is a discovery call. It's not a sales call. I might not be able to help you, but at least I can point you in the right direction if I can't help you, or if I can help you, I can talk about how I can help you. But as of right now, I can't help you because I don't know what your environment is, and it would not be actually good form to just think I can sell you on the discovery call. That's just not going to happen. So the link's going to be in the description. Hopefully this video was informative. Thank you and have a nice day.